We're doing a project this week. Check it out. This is an audio spectrum analyzer written in Solid. It runs at 60 frames per second. And we're going to walk through the implementation on this. I'm going to show you every single detail as we go. We're going to learn a lot about Solid and how it handles data. We're going to use D3 without using D3. And we're going to use the audio context API to make all this happen. Let's jump right into it. Okay, so what are we looking at here? Well, we're actually looking at a bar chart, if that makes any sense, kind of wrapped in a ring. And it's created by Solid, rendered in SVG, and it's actually running an MP3 file that I have downloaded locally. So first step is to create our Solid app, and then the second step would be to bring in our MP3 file and start getting it analyzed like this. So, okay, let's jump out of full screen mode. And then I'll go over to the Solid page and go to Getting Started. Now we're going to use TypeScript for this. So for the TypeScript variant, I'm going to use this dget pattern. Put that into my iTerm. And we'll call this Solid Spectrum Graph. And then I'll bring that up in VS Code. Now let me do yarn to install. And then yarn dev to run. All right, looks like the usual Solid template. Let's start hacking on that and trim it down a little bit. Okay, a good empty starting point. So the next thing we want to do is we want to have that MP3 file. Now, of course, all of this code is available to you on GitHub for free, but I can't give you that MP3 file because it is licensed. So you're just going to have to go get your own MP3 file, get whatever you want, whatever song you want to listen to and visualize. I leave that up to you. Now, where do you put it? Well, you put it in a public directory. So let's make that at the top level. And I'm going to drag in here this epic trailer.mp3. Now, to make sure that that works, we need to go over to the site and then try to access it. Okay, looks good. So it's on the site. That's great. I'm going to then copy this because the first thing we want to do is we want to bring that into our JavaScript ecosystem. So really we have two sides to this app, right? We have the data side, which would be the audio. And then we've got the visualization side, which would be done in Solid. So I'm going to make another file and it's going to be our audio source. And into that, I'm going to have a function called start from file. That's actually going to be an asynchronous function because we need to make a request to go get that data, and that's going to be asynchronous. So the first thing we need to do is a fetch to go get the data. And I give it the exact same thing as we had before, that epic trailer.mp3. Now that's going to give us back a result. And where we normally would do something like JSON or text, if we're getting textual data, in this case, we're getting a file. And a file is just an array of bytes. So what we ask for instead is an array buffer. All right, let me put a weight up here. Make that a little bit cleaner. Okay, now we have our byte array, and what we need to do is convert that into an audio file. And the way that we do that is we use the audio context. Most of the stuff that we're going to do runs through this audio context, so let's create one. And then with that audio context, we can make our audio file. So we use decode audio data to do that, and we just give it that byte array. Now that's asynchronous as well. Okay, cool, we have our audio buffer. Now we need to make a source out of it. And now a source can be multiple things. It could be like a microphone or a file in this case. So we need to create a buffer stream source. And then we attach the audio buffer to that source. Of course, we want to see if this actually plays first, right? So let's go and take that source and connect it to the context destination. Now the destination on the context by default would be the speaker. So let's go and connect it to the speaker. And the last thing we need to do is just play it. Okay, so let's bring this into our app. And you know what? Let's just start it. Now we'll go over to our page. And let's see, it's not starting. So why is that? Well, if I go over to console, it gives us this handy little error message. The audio context is not allowed to start. It has to be created or started with a user gesture. And that's really cool. That's basically the browser protecting us from people just having audio that just boom pops up on a page without the unsuspecting customer like being aware of it. So we need something to trigger it. So in this case, that would probably just be like a click on it. So we can just respond to a click by starting our audio source. So let's go back over here to our div and then say on click, start from file. Okay, cool. But now the hit target on that div is super small. So let's make it bigger. This will make it the entire width of the page, and then we'll make the height the entire height. All right, let's give it a try now. Whoa, nice sound. Awesome. So now that we're playing the file, we need to get the data out of it. We need something to visualize on our kind of roundy bar chart. And what we're going to visualize is the spectrum of the audio, not the signal of the audio. So why is that? Well, let me jump over into iZotope and show you. So this is iZotope. This is a professional audio editing software that I use to produce the audio on these videos. And what it's showing us here is it's showing us the actual time signal data. So this is just the signal over time, the signal in the time domain. And this is what goes out to the speakers, pushes them back and forth, drives the air, and that's what gives you sound. This is one way of visualizing sound. Another way to visualize sound is to visualize it in the frequency domain. So you can do that by just pulling this slider over, and now it shows the spectrogram. Now the spectrogram is the exact same data, but just shown in the frequency domain as opposed to the time domain. Now you can see it goes from the low frequencies at the bottom to the high frequencies at the top. This is the left and right channel. So here, there's a lot of frequency in the low end. You can see that over here, but there's not a lot of frequency up at the high end down here. So that it's a very bassy song, not a very trebly song. So this histogram, this is what we want to plot. And the way that we get the histogram is we run a fast Fourier transform on the signal data, and that turns the time domain into the frequency domain. Now, all we need to do is just implement an FFT. Of course, we don't want to do that. But the nice thing is there's an FFT built into the audio context. So let's go try that. So back in our audio source, we're going to create an analyzer. And then instead of connecting our source to our destination, we're instead going to just connect it to the analyzer. Now we could in turn connect the analyzer to the destination. And what that would do is play the audio, play it through the analyzer, and then up into the speakers. If you want to do that, that's fine. If not, if you don't want to listen to the same song over and over and over again, just comment this out for the time being. Okay, so now we have our analyzer. We need to configure it. We need to tell it how big of a sample to use for our fast Fourier transform. So the way we do that is we give it the FFT size, FFT for fast Fourier transform, and it has to be a power of 2. So I'll just use, in this case, 512. Now 512 is actually going to only get us 256 samples because of the way that an FFT works. Now we need some place to put it. So we need to create a buffer. So I'm going to get the length of that buffer from the analyzer. So this is giving us the number of bins. So what's a bin? Well, in a histogram, a bin is a range from a low end frequency to a high frequency, and you segment up an entire frequency range into bins of frequencies. It's not a particular one frequency, it's a range, like 10 kilohertz to 11 kilohertz. And then it just adds all of the power that's within that frequency into that bin. So now we need to create a data array to hold the data from the analyzer. And it's going to be an array of bytes, where those bytes are from 0 to 255 in value, and it's going to be of that buffer length and size. And then finally, we need to ask the analyzer to fill up that data array with a sample of the frequency. So we do get byte frequency data, and then we just give it that data array. Now for the time being, all we need to do is just put out the console, see if we actually get anything. We'll do an array from to convert our data array into an array that we can see. And there we go. Let's try it out. Now let's go over to our console and see. Cool. So now we got a whole bunch of numbers and they all start off at 0. That's fine. They will get larger as you get more playback. But we're actually getting data, so that's a good thing. So what we need to do is go into a continuous loop around this get byte frequency data. Now we could use an interval for that, but because we want to connect this to the frame rate that we want to hit, which is at 60 FPS, I'm going to use instead request animation frame, which tells the browser, hey, anytime you're going to render a frame, give me a callback first, let me do a little data manipulation, and then go and let you run the frame. So to do that, we need to put this get byte frequency data into its own function. And then we need to use request animation frame to call that. Now that's only going to happen once. We're going to request the animation frame. It's going to trigger, it's going to call update, and then that's it. So what we need to do is have update also call request animation frame on itself to create a loop. Okay, so now we have to connect this data array to our Solid application. And that means modeling this data the way that Solid models data, which is as a signal. Now a signal can be internal to a component, like local state, or it can just be external. So in this case, I'm going to create an external signal. We'll call it raw data. Now it's going to be an array of numbers, but because we're in TypeScript, we need to type it. And in this case, this is a never array, not a number array, because we don't know if there's going to be numbers in here yet. If we put in numbers, then that would be a number array, but we're just starting with an empty array, so we need to type it. So the way that we do that is to use the generic. Now we've specified that this has to be an array of numbers. So now all we need to do is come down here and do that set raw data and give it that array. Awesome. Okay, now we have a raw data, so let's export it and then bring it over into our app. Now in here, we can just JSON stringify it. Now the trick is you don't have just the data as raw data. Raw data is a function, and when you call the function, you get back the data. But it also subscribes to raw data, so that when raw data changes, only this section in here is actually going to get updated. That's one of the really cool things about Solid as compared to React. This app component only runs once, and then from then on, it only changes anything that responds to changes in signals. So like this raw data. So let's hit save. All right, here we go. Clicked on it and voila, data. Now all we need to do is visualize it. So let's get out our D3 and turn this into a radial graph. All right, let's go back over into our code and I'll add D3 and then I'll add the types for D3. And then I'll run the app again. So D3, if you're not familiar with it, is a graphing system. It used to be a system where the math of the D3 system, the math to like figure out axes and arcs and stuff like that, was all bound up with the same code that would do the DOM manipulation. And he's actually refactored those two into basically two different parts. So now we can use, for example, the arc, which calculates an arc on its own from the DOM manipulation stuff. So we're going to let Solid do its work with the DOM manipulation, but we're going to do the math in D3. Now to do that, we need to bring in arc. This is an arc calculator. It basically, you give it a starting angle, an ending angle, an inner radius, and an outer radius, and it creates an SVG or scalable vector graphics path that then you can fill with some color and you get a slice of an arc. So the next thing we need is an SVG surface to put that into. So we're going to go down here and create the SVG tag. And we'll say that it takes up the full width and height. And then we'll specify a view box. So what a view box does, and this is awesome, is it allows you to create a virtual coordinate space within the SVG. So that instead of writing from 0, 0 to the maximum number of pixel width, maximum number of pixel height, and having to do all that scaling yourself, you instead draw your graphics relative to that virtual coordinate system of the view box. And then the SVG system actually scales it to whatever size the current width and height is. So we're going to specify a view box, and it's going to start at -100, -100. So that would be over in this corner. That would be the top left-hand corner. And then the bottom right corner is specified by adding a height and a width. So we're going to give it 200 for the width and the height. That means that the center point of this screen is 0, 0. The top left is -100, -100, and the bottom right is now 100, 100. Which makes it really easy to draw graphs because anything you draw is going to be naturally just centered in the middle of the screen. Super awesome. And then the last thing we want to do is preserve the aspect ratio so we don't get any warping. Okay, so now we're going to create our radial graph component and have it go and put paths inside of our SVG. Now, a nifty container inside of SVG is a group. You can just create a group tag and then have a lot of items within it, just kind of like a div, I guess, in normal HTML. And it's just G. And then inside of that, we're going to have a path. And that path is going to have some path. The term is D. The attribute is D. I'm not sure why it's D, but it's D. And then you do a fill. Let's say black to start. Now let's just create an arc to see how this works. Now to create an arc, we need to invoke arc. That will give us an arc builder. And then with that arc builder, we can create an arc. So to use arc builder, you give it an inner radius, an outer radius, a start angle, and an end angle. So let's do the inner radius and outer radius first. And we'll start at like 10. And then the outer radius will go to, say, 90. And then we have to give it a start angle. So let's start our start angle at 0. And then we give it an end angle. So now we need an end angle. Now both start angle and end angle are in radians. Radians are relative to pi, and a complete circle is 2 pi. So let's just use, say, math.pi. That should be half a circle. And now we have a path, and let's just put it in there for the D. Ta-da! So now we need to go and kind of connect this to our signal data. So the way that we do that is that we create a memo. So the same way you have use memo in React, create memo takes a signal and derives some new data from it. So in this case, we are going to take our raw data and turn that into paths that we're then going to plot. So let's take the type out of there and then bring in create memo. So we're going to have our create memo create paths. First, we need the data. And then we're going to draw slices for each one of the pieces of data. So we're going to have an angle to start. And let's just set that to 0. And then let's iterate through all of those pieces of data. And now in here, we're going to use that path. We'll have that inner radius and outer radius for each one. So the inner radius, let's actually calculate this out. So we want the size of it to be dependent on the actual value of the data. So D, right? So what we can do is we can start at 50. And in the case of the inner radius, we want to subtract the value over 255. So that would take it between 0 and 1 times some width factor. So let's say that we want the whole thing to be 70. So in this case, we probably want this to be like 35 because we want the numbers to go from 50 to 15. And we want the outer radius to go from 50 to 85. So we'll take this same thing and we'll just copy it, paste it, and change that to a plus. So the starting angle is just going to be that current angle. And the ending angle is going to be, well, that current angle plus something. So let's just go with pi times 0.1 or something. And then we'll increment the current angle by that value. Okay, so now we have a path. And we need to return out of this create memo an array of paths. So we need to have some place to store that. So let's create a local, which is going to be an array of objects. And in that object, we're going to have a path and then a color, because we're going to want to colorize each one differently. And we'll start that off at an empty array. And we'll take this path and we'll push it in there and give it some color, maybe blue. Okay, cool. Although it says that this could be null coming out of Arc Builder, but let's just use TypeScript's bang and tell it, hey, it's going to be a string. Don't worry about it. We got this. Last thing we need to do is return our list of paths. So now we have an array of paths as opposed to one path. So we need to iterate through that array of paths to create a bunch of paths. So to do that, we use the for tag in Solid. All right, let's just try it out first. All right, let's put it in here, for, and then you got to give it something to iterate over. So you do each, and you give it the signal that you want to iterate over. So in this case, that's paths. And then within that for, you give it a function, and that function renders tags for that particular item. So in this case, let's go take out that path, make this a function, and then drop that in there. And now that we get a path value, so we'll do p.path, and we'll give it a fill of that color. All right, this actually might work. Let's give it a try. Whoa, okay. That actually kind of works, although it's not quite right. I mean, these slices are way too big. So the problem there is that this math.pi times 0.1 is just too big. So how do we calculate out what math.pi should be? Well, we need to figure out first how big we want our circle to be. So if 2 pi is the whole circle, maybe we want like 1.8, which would be kind of most of the circle, like a big horseshoe. So let's call that range. And then let's create a range in radians, which would be that times math.pi. And then we want to calculate an angle, which is that range in radians divided by the number of items in data, because that'll give us essentially, 1/256th of that whole section. So let's try that. And we just give it data length. Now we can use this angle instead of math.pi times 0.1. All right, let's give it a try. Whoa! Wow, that looks really cool. So I'm liking this, but there's a few things that we need to work on. First, I want it to actually start kind of over here. So let's take that starting point and kind of move it back. So we'll create a starting angle with the negative range in radians divided in half. And we'll use that as our starting current angle. So let's drop that down there. Make that the start angle. Nice. Okay, I like that. Another thing is that I don't like it just completely disappearing like that. I'd like to have some kind of, it's always going to have at least something on that bar item. So let's add, say, 10 to this D value. And now we always have at least something to see. That's great. The other thing is I don't like the way that this line is like on the edge there. I want that more to be in the center, and I kind of want it to just kind of come out. So maybe we just like duplicate the whole thing and have this big line be in the middle. So the way that we can do that is going to go back in this audio source and kind of hack this a little bit, because we know that basically the graph will now plot anything that we give it. So we could give it even more numbers. So let's go and take this array and we'll just duplicate it. So put two arrays in there and then flatten it so that we have one contiguous big array of numbers. Wow, pretty cool. Okay, but now we want this first part to be reversed. So let's do that. And now that's kind of interesting. And that's a problem with reverse. Reverse is actually an in-place reverse in JavaScript. So when you ask an array to reverse, it actually reverses the array itself. It doesn't return to you a reversed array. So what we would need to do is clone this original array and then reverse that. So the way we do that is we clone it and then reverse that. Nice. Okay, now this is actually starting to look a little bit more like what I showed originally. All right, this is really cool, and it's looking a lot more like it did originally. One thing that the original one had was it had more color to it. It wasn't just blue. So we can use some D3 helpers for that. There's a set of functions called interpolators that you give it a number between 0 and 1, and it gives you back a color based on that. And I'm going to use interpolate sine bow, which is going to give us a rainbow, I guess, based on sine waves. It's pretty cool, actually. So let's try that. Interpolate sine bow. And now let's see. So color here, we'll just take blue and replace it with interpolate sine bow, and we'll give it that data value over 255 to range it between 0 and 1. And now we have beautiful rainbows. This is actually getting very close to what we had originally. The original one did something a little bit differently, though. The bigger the amplitude of the particular slice, the wider the slice. So in this case, the angle was dependent on the data. So the way that we can do that is we can basically sum up all the numbers and get a total, and then we can take the current value divided by that total, and that gives us a percentage of the overall signal size, and we can use that to specify the angle. So let's first sum up all the data into a total. For that, we'll use reduce. Reduce takes a function which takes an accumulator and a current value, and we'll just add the value to the accumulator, and then we'll start off the accumulator at 0, and that gives us a total. Now down here, we can say that our angle is that range in radians multiplied by the current value over the total value. Let's see, does this work? Oh, wow, that is really cool. As you can see, like when this red bar is really big, it gets big. It's really cool. I love how this is going. So one of the things that we did in the original that this one isn't doing is the graph actually got bigger as the intensity grew. So right now the range is 1.8, but as the intensity of the sound grew, that ranged from like 1.0 to 1.8, depending on that intensity. So we need to come up with some measure of intensity. And the way that I did that was I took the number of samples that were over a certain threshold over the total number of samples. So if the total number of samples that were high, big, were large, then that intensity would be a large number between 0 and 1. And if it were low, like there just wasn't a lot of like big samples, then it'd be low. So let's go and build that. So we want to create a count of all the high values. So we'll say that a high value is anything over 32. And this will filter the data so that we now have an array of all of the values over 32. And now we just need to get the length of that. And that tells you the number of samples that were high. Now to calculate the intensity, we just need to take the high count and divide it by the number of items in our array. Cool, now we got this intensity value that ranges between 0 and 1. So let's just take range back to 1.0 and then add the intensity. Let's give it a try. Oh, neat. Okay, let's hit it again. Yeah, and as we can see, like the crescent gets bigger as the sound grows. That's just really, really cool. Okay. Now, one more thing that we did was we changed the scale of it. So the actual graph got bigger as the intensity grew. And here's one of the fun things about SVG is you can actually scale things really easily. The way that you do that is you scale inside of a transform. So you give a transform value and you say scale with some factor. Now it's just twice as big. So let's scale based on the intensity. So it's going to be the intensity, say, times 2 plus 1. So you give it a lower boundary. But now we don't have intensity because intensity is over here in this create memo. So what we can do instead is have this create memo, instead of just returning paths, return paths and intensity. So we'll say that this is the computed data, and it's going to return an object that includes paths, but also has intensity. And then down here, we can dereference intensity off of computed. And the same thing with paths. Boom! Wow. And we're getting really close to what we had before. But is it 60 FPS? Let's take a look. So I'm going to go over here into the inspector and then click down here, select rendering, and then put on frame rendering stats. And we can see up here, yep, 60 FPS, 59.3. Awesome. How fast is that? So one more thing that we added on the way to having the complete thing was the original had actually two of these layered on top of each other, each that had a different coloring. So what I need to do is pass a coloring into this radial graph. So we're going to give it a color function. It's going to take a value as a number and return a string. And now we bring that in as a parameter, color, just like we do in React. Come down here, let's see, interpolate sign bow now becomes color. And now we just need to pass it in as a property. Boom, nice. All right, so now we want another radial graph. And we want a different interpolation, different palette. And the one that I used for the second one was Inferno. Now, the great thing about all this stuff is you can do whatever you want with this. You can use different palettes. You can use different equations. It's totally up to you. So let's put in Inferno and see what happens. And now we can't really see it because the two graphs completely overlay each other. So what we need to do is give them different scaling factors. So we need to make scale another property here. So let's go up here and add scale. And then come down here and replace this 2 with a scale. Now we also have to bring it in as a argument. Nice. Okay, cool. Looks good. And now I can make this Inferno, let's say 1.5. And this sign bow 2.5. Oh, that's neat. I like it. Wait, hold on. One's on top of the other. Let's move this around. Okay. Ooh, that's cool. Wow. That is really neat. I guess the last thing to do would just be to make the background black. So let's go back over here to our index.css and make the background color black and give ourselves no padding and no margin. And there you have it. A wicked cool audio visualizer, solid 60 FPS, all kinds of cool visualizations. I love it. And of course, all of the code minus the MP3 file is for you on GitHub for free. Follow the link in the description below. And of course, if you like this video, do me a favor, hit that like button. That's the way that YouTube recognizes this as a cool channel. And of course, if you really like the video, hit that subscribe button. Click on that bell and you'll be notified the next time a new Blue Collar Coder comes out.